So let us see the problem. How to write a problem? So given the line AB inclined at 45 degrees to 40 degrees to VP. A line AB inclined 40 degrees to VP. Has its one end, as its ends 30 mm and 50 mm, 30 mm and 50 mm above HP respectively. Front view is, length of front view is 65 mm and VT is 12 mm above HP. Draw its projections. Okay, and also determine its true length and inclinations. Students, is it clear now? The problem is AB is 40 degrees into HP. AB is 40 degrees inclined to HP. Its ends are 30 mm and 50 mm above HP respectively. Front view is 65. Front view measures 65. And VT is 12 above HP. Now let us write the given data. So given line AB makes inclination 45 degrees to VP. So AB is nothing but true length. So we don't know the true length. But this true length is making 40 degrees to VP. So true length inclination with VP is denoted by, true length inclination with VP is denoted by phi, which is equal to 40 degrees. Has its ends, okay, 30 mm above HP and 50 in front of VP. Sorry, both 30 mm and 50. Ends means both A and B. So that is A is 30 above HP, comma, B is also 50 above HP. Front view measures. Front view is 65. When front view is equal to 65, we know that front view is A dash, B dash, which is equal to A dash, B2 dash. Front view is represented by A dash, B2 dash. Okay. And he also gives VT. VT is 12 mm above HP. Okay. So this is the data. What to find? To find is, what to find? We had to find its front view and top view. Okay. Theta, phi, alpha, beta, and also true length. Okay. And what we know for this problem, first of all, we just had to know about what are the points which are lying on the same locus line, that is A dash, B dash, H, comma, VT, A, comma, B, comma, V, comma, HT lies on same line. Okay. Now let us see the problem. First of all, I just draw my reference line XY. Okay. Students, is it visible? Students, is it visible for you? Okay. So from the given data, I know that point A is 30 above HP. So this becomes locus of Above HP means it is all front view, that is A dash. Next, B is 50 mm. Locus of B dash. VT is 12 mm. Locus of VT. So this is 12. This is 30. This is 50. Okay, all are above HP. 30, 50, and also VT 12. Okay. Next, we know that front view is equal to 65. What we know? Front view is equal to 65. So from the given locus of A dash B dash, what we can do? We know front view. I just take any of the point on locus of A dash. And somewhere right here, this becomes my A dash. And I know that A dash B dash is equal to 65. So I know my point A dash. And I know locus of B dash. A dash as center, 65 as radius, draw an arc to obtain B dash. Okay. So if you join A dash with B dash and extend, it meets the locus of VT. Why? Because A dash, B dash, H gamma VT lies on the same line. So I know the locus of VT. If I extend A dash, B dash up to locus of VT, I obtain my VT. Okay. So from VT, if you draw the vertical projector downwards, it becomes V up to XY. Okay. Now, from the given data, we know, so we already placed A, we already placed B point, front view we already obtained, VT we are only remaining is phi equal to 40. So phi equal to 40 means where it should be obtained on the horizontal plane. That means inclination with respect to VP. That comes above, that means always below XY line. So below XY line inclination phi equal to 40, where it is going to be taken. So where is the point to have to draw for 40 degrees? For me, only top view point is going to be V. Why? Because in the top view that is A, B, V, H, T. So I didn't have A point. I didn't have B point. I have V point. I don't have HT. So let us assume, so one of the point on the top view is V. So from V, I just draw a line of 40 degrees. I just draw a line of 40 degrees. Okay. Next what we can do? Next. Students, is it visible for you? Is it audible and visible? Okay, can you tell me? Now tell me what is the next step? Draw vertical line downward. So draw vertical line downward. Someone are saying that it is not visible, it is visible. For me, it is visible, I think so. Now is it okay? Now is this okay? Okay. So now if I draw the vertical projector from B dash, vertical projector from B dash, so it meets the V point at somewhere, then it becomes B. If it top view is B dash, front view is B dash, top view becomes B. Now I draw a line passing through B. This becomes locus of B. Okay. Now, if I draw the vertical projector from A dash up to here, so this becomes your point A. If I draw a line passing through this point A, this becomes locus of A. Locus of A. Okay. Now I obtain my AB. Okay. So now can I say if I consider VTB dash and VTB is going to be my front view and top view. So if I take VTB dash as radius, draw an arc up to locus of VT to obtain B2 dash. Once you obtain your B2 dash, so why? Because I just consider my line is VTB dash. If VTB dash is front view, VTB dash is front view, VB is going to be your top view. Okay. So we know that while we are going to be do the previous problems, A dash as center, A dash, B dash as radius, diagonal to obtain B2 dash. So similarly, I just consider VT as center, VT, B dash, diagonal up to locus of VT. So if it comes vertically downwards, so this becomes your B2. Okay. So now if you consider, if you are supposed to join now V with B2. V with B2. This VB2, wherever it is supposed to cut your locus of A, this point becomes A2. A2, B2. Okay. Similarly, I just consider my V as center, VB as radius. Okay. Now let us see now. So is it clear up to now? Students, is it clear up to now? Is it okay up to now? Now I consider my A as center, AB as radius. Why? Because I already have my point A dash and A. So which is going to be the full form of your point I defined. So I just consider my A. Okay. So A as center, AB as radius, draw an arc. So this becomes B1. If you obtain your B1, draw vertical projector upwards, this becomes B1 dash. Now join A dash with B1 dash is nothing but your true length. This is theta and this is alpha. Okay. And this is Students, I just repeat this problem once again. All of you just see there was a little bit confusion. You erase this confusion and I will do it one by one. Okay, let us see. First of all, draw a line XY. Point A is 30 above. Point B is 50 above. Locus of, all of you listen carefully. All of you just see here. Locus of B dash. Locus of BT. Okay, so this is given 12, 30, 50. All of you now see, I just consider my point at somewhere at locus of A dash at here. So this is A dash. Okay. So I know that A dash B dash is equal to 65. A dash is center, 65 as radius, then R from locus of B dash to obtain B dash. Now join A dash with B dash and extend A dash B dash up to, so this becomes your VT, and if you extend some more up to XY, you will obtain some H. Okay. Now, so once you know your VT, if you draw the vertical projector up to XY, this becomes your point V. So this is the thing we know. And next we know that given phi is equal to 50 degrees, so we have only the top view point is going to be V, so which is here. So I just take V as center, I draw a line of 40 degrees. I draw a line of 40 degrees. Now, so somewhere I had mislead V that, so take a B dash and center, draw the vertical projector to B. So I don't know this was the line of B dash, where I am supposed to obtain my B dash. So, but I know only VT B dash is going to be the front view. Okay, why? Because so this front view point and top view point are known, then only that point is considered for center of rotation. So I know my VT and V, the full-fledged point is known. So that is the point to consider for the center of rotation. So VT as center, VT B dash as radius, draw an arc up to locus of VT. So once you just have to remind the problem, point, wherever you are taking the center of rotation, if you start rotating with that radius, you have to rotate up to that locus of that point only. So this becomes your B2 dash. Now, if you draw the vertical projector from here, if you extend this line to some extent, so this point becomes your B2. That point becomes B2. Now, if you draw a line passing through B2, this becomes locus of B. That becomes locus of B. Okay. Now, if I know my locus of B, if I draw the vertical projector downwards, now I am supposed to obtain my point B. Okay. Now I am supposed to join B with V. Now I am supposed to join B with V. Why? Because I know that A, B, which T lies on the same line. So this B and V are going to be lies on the same line. I get my VB. Now, if I draw the vertical projector from A dash, if I draw the vertical projector from A dash, it cuts the VB line at a particular point. It is point A. It is point A. Now if I draw the line passing through A, this becomes locus of A. Students, is it clear now? Students, is it clear now? Now you obtain point B and we are join B with B. Okay, if I draw the vertical projector from A dash, it will meet the VB at particular point A. Why? We know that A dash and A lies on the same vertical projector. Okay, now I know my A dash B dash is known, top to AB is known. Now I can take A as center, AB as radius, A as center, AB as radius, draw an arc up to locus of A. This becomes B1. Once you know your B1, you just draw the vertical projector upwards. You can draw the vertical projector upwards. This becomes B1 dash. We already know that B dash and B1 dash lies on the same locus line. Now you can join A dash with B1 dash. Now you can join A dash with B1 dash. So A dash with B1 dash inclination is theta. A dash B dash inclination is alpha. Similarly, we know that. So this is the line which is supposed to cut VB2 is nothing but your, this is A2. Okay, the line making inclination with A2 B2 is nothing but 40. Okay, and inclination with AB, this inclination with AB, this becomes your beta. Okay, now I know that. So A dash B1 dash gives my true length. So this was true length and A2 B2 also true length. Okay, so once I know my point HTV and H, if I simply extend ABV to some extent, if I draw the vertical projector from here, it becomes HT. So from that we can say that A, B, V, HT lies on same line. A dash, B dash, H, VT lies on the same line. Okay, students, is it clear? Make it fast. Students, is it clear now? Yes, someone had given me very good point. Yes, A dash, B2 dash is going to be lights on the same line in general. But when I consider A dash, B2 dash must lie on the same projector line, when I consider my rotation center as A dash, if I consider A dash as center, A dash, B dash as radius, then B2 dash comes at here. But what I consider VT as center, VT, B dash as radius, I draw. Why? Because means while you are going to take the center of rotation, you just have to know the full details of that point, that is front view and top view. So here A dash is only known. I didn't know point A. So front view is known, top view is unknown. So I cannot take the center of rotation as A dash. I take center of rotation as VT. Why? Because I know VT and its top view, that is V. So VT as center, VT B dash as radius, down up to locus of B dash. Locus of VT dash. So that becomes B2 dash. Is it clear now? So I can't do anything. Have put their thumbs down. So that's yours. I can't do anything. So this is So write another problem. So which is in HTVT, which we discussed previous day. Oh, make it fast. The line AB has its end. The line AB has its end A. $20 and end B is 50 in front of VB. Can I erase this? Students, can I erase this? Students, can I erase this? All of you write this problem. The line AB has its end A point is 20 in front of VP and B point is 50 in front of VP respectively. Distance between projectors is 70. Distance between A and B projectors is 70. Line is inclined. AB line is inclined 35 degrees to HP. HT is 15 mm above HP. Draw its projections. Students, is it okay? Why you put your thumbs down? Board is not visible for you. Now, hey Harshavardhan, can you please stand up? So what are you doing, man? So why are you in the class? So what the hell are you doing? You are sleeping? Students, is it visible now? Now is it clear? So now let us see from the given data. What is the given data for the problem? So given the line, the point A is 20 in front, B is 50 in front. Next, distance between projectors is given. $70. So HP inclination is given. AB line means true length. AB means true length. True length inclination with HP is theta. Theta is equal to 35 degrees. HT point is given. HT is 15 above HP. Okay. So first of all, what is the point we have to know for HTVT? A dash, B dash, H, VT, A, B, V, HT. Make it fast. I am just doing it fast. So first of all, I just draw my line XY. Given point A is 20 below and B is 50 below. So this is locus of A, locus of B. Next, HT is given. Locus of HT, which is 15 above HP. Okay. Now let us see how can we do this problem. The distance between the projectors is given. Okay. So let us consider a point A at anywhere here. For example, this becomes my point A. Okay. So from point A, I just draw the vertical projector. From here, I just take another 70. I just draw another projector. The distance between AB projectors are, for example, this is end A, this is end B. The distance between A and B projectors are 70. So this is locus of A, this is locus of B. So this is B. Now if I join, now I can join A with B. Okay, and I know that AB, V, HT lies on the same line. I know locus of HT also. I know locus of HT also. So what I can do, I just increase the lengths. So this is locus of HT. So this becomes HT. Why? Because I know A, B, V, HT lies on the same line. So if it comes to XY, this becomes H. Okay, that becomes H. So I just take A is over, B point is completed, HT is completed, distance between projectors is completed. Now I have only theta. So theta means that always comes above xy. So where it is to be obtained? So my front view points are going to be only h is available. So from h, I just draw a line of 35 degrees. So this is 35 degrees. Okay. So now I know that. Now what we are going to be taken as the center for rotation? I know my point HT, H, AB in the top view. Okay. So now my known point is HT. So why? Because the full form of the HT and H are going to be known. So HT as center, HTB as radius. So draw an arc up to locus of HT. Locus of HT. Okay. So let us consider this is some point P for your convenience, or you can take it as our B1, AB equal to AB1, or you can take it as point P for my reference, or you can consider as B1. If I take vertically upwards, what it happens? It cuts the point at somewhere at here. This becomes your B1 dash. If I draw a line passing through here, this becomes locus of B dash. Once you know your locus of B dash, okay. So if you draw the vertical projector upwards from B, so this becomes your B dash. Now I know that A dash and B dash HVT lies on the same line, and I know my point H and I know my point B dash. Now I can join so this becomes your alpha. So once I know my H and B dash, so in between H and B dash only I am supposed to obtain my A dash. So if you project here, this becomes your A dash. So if you draw the vertical line passing through here, this becomes locus of A dash. And wherever this HB1 dash is supposed to cut the locus of A dash at a particular point, let us consider it as A1 dash. Okay? Now I know my A dash and A, which is going to be the full form of the view. That means the top view and front view are known. So A dash as center, A dash, B dash as radius. Draw an arc up to locus of A dash to obtain B2 dash. Once you know your B2 dash, if it comes below XY line, it changes to B2. It changes to B2. Now join A with B2. Now join A with B2. Okay. So A B2 is nothing but your phi, and this is beta. Okay. And A B2 is nothing but your true length. So A B2 and okay. So all of you just complete this. Students, is it clear now? Is it clear?